I've been requested to do some problems on critical points and maxima, minima, and concativity, so I will do some problems. So these were sent to me by Akash. I don't know where he is, but these are interesting problems, and I haven't done anything like these before, so I thought I would do the exact problems he's given. So the first problem says, identify the critical points and find the maximum and minimum value on the given interval. And they say f of x is equal to x squared plus 4x plus 4. And the interval that they care about is from minus 4, and including minus 4, that's why we have the brackets there, to 0. And just so you know, this interval notation, if it was written like this with parentheses, it would mean all the numbers between minus 4 and 0, but not including them. This means that this is a closed interval, so you're including minus 4 and you're including 0. This is called an open interval. But anyway, you could ignore this because that's not what was in the problem. So the first thing they ask is, what are the critical points? And different people use different terminology, but my understanding is critical points are all the points that are interesting. So it's the points where the derivative is equal to 0 or the derivative just doesn't exist. But as we see in this interval, let's take the derivative. F prime of x is equal to 2x plus 4. So when does this equal to 0? Let's see, 2x plus 4 is equal to 0. 2x is equal to minus 4. Right? I just almost made a mistake there. X is equal to minus 2. And when x is equal to minus 2, what is f of minus 2? So we know that f prime of minus 2 is equal to 0. We just solved for that. So we know the slope is 0 at that point, but I just want to know what the coordinate point is. So f of minus 2, it's 4 minus 8 plus 4. So f of minus 2 is 0. Let's evaluate the function at the endpoints of this interval. F of minus 4 is equal to minus 4 squared is 16 minus 16, right? 4 times, so that's 0. And then plus 4, so f of minus 4 is 4. And then what's f of 0? F of 0 is equal to, well, that's 0, 0. It's equal to 4. So now we could graph this. Let me graph the difference. So if this is the x-axis, draw the x-axis. If that is the x-axis, and that is the y-axis, and the interval that we care about is from x is equal to minus 4, from minus 4 to 0. So the first thing they said, well, identify the critical points. Well, the critical points were when the slope is equal to 0, and that's at f is equal to minus 2, and that happens at the point minus 2 comma 0, so it's right here, which is directly in between those 2 points, incidentally, which is a good intuition behind why these two values are equal, because this is a parabola and it's symmetric. So if you go 2 away on either side, the function should have the same value. But anyway, ignore that if it confused you. So at minus 2 we have a negative slope. F of 0 is equal to 4, and f of minus 4 is equal to 4. So the graph is going to look something like this, and I'll do it in another color. The graph, and since we only care about that interval, let's only graph it over that interval. It looks something like that. And as we said, this was a critical point, and they want to know the maxima and the minimum point. Well, the minimum point is pretty clear. It's this critical point right here, where the derivative was equal to 0. And if you wanted to use, whatever they call it, the concativity theorem, but hopefully you have the intuition of why, you would see that the second derivative at this point is positive, right? And what's the second derivative? If that's f prime of x, f prime prime of x for all x is equal to 2. So really, this thing is going to be, at any point you test, you're going to get the second derivative to be positive. So especially at this critical point, where the first derivative is 0, the second derivative being positive tells you that the slope is constantly increasing. So the rate of change of the slope is positive, right? The slope is really negative there, a little less negative, goes to 0, and then keeps increasing, becomes more positive, even more positive slope there. So I think that was out of the scope of this exact problem, but it's good to have that intuition. And then they want to know the maximum points. Well, the value here at x is equal to minus 4 and the value at x equals 0, they're both maximum points. They tie for first place. So those are the maximum points. 0, x equals 0 and x equals minus 4. You could say 0 comma 4 or minus 4 comma 4. What's the next problem they give? Let's see. I find these problems, the understanding the problem is often, and the terminology is often more confusing than the problem itself. So they give h of r is equal to 1 over r, and they care about the interval. They care about the interval. I'm assuming from, this is an interval on r, from -1 to 3, and we're going to include -1 and 3 because we have brackets. Well, what are the critical points? They're the points where either the derivative is 0 or the derivative doesn't exist. Now, this brings up an interesting point, right? Because, well, we'll see in a second, there's a point here where the derivative doesn't exist, but the function also isn't defined at that point. So that's not a critical point. So in order to get a critical point, and this is a bit of a technicality, critical point, the easy one is derivative is 0. Derivative equals 0. The other critical point, and I was a little bit non-rigorous with it when I said it before, is when there's no derivative. There's no derivative, but f of x is defined. So as you're going to see in this problem, there is a point where the derivative is undefined, but f of x is, or in this case, h of r, is also not defined at that point, so it won't be a critical point. Or maybe it is, I don't know, depending on how your teacher defines it. But the way I learned it is, a critical point if the derivative isn't defined, but the function is. But anyway, well, what's the derivative here? H prime of r. Well, that's r to the -1, right? So it becomes negative r to the -2, or that's minus 1 over r squared. That's the derivative. Can this ever equal 0? Well, no. It's never going to be equal 0. But where is it undefined? Well, it's undefined when r is equal to 0, and r equal to 0 is in that interval, right? So h prime of 0 is undefined. But h of 0 is also undefined, right? 1 over 0 is undefined. H of 0 also undefined. So I'm not going to really consider that to be a critical point, frankly. It's just a point at which the derivative and the function is undefined. And so what will the graph look like? Well, let's see if we can draw the interval. And we might just want to draw some points. And that's what I always used to do if I ever got stuck on a math problem. I would just graph some points. You can never go wrong with that. Let's see, 1 over r. So we want to go from -1 to 3. So we're going to have some negative values. So we want to go from r. This is the r axis, right? Because this is a function of r. This is the h of r axis. So we're going to go from r is equal to -1 to r is equal to 3. To r is equal to 3. And we could plot some points. What is h of -1? It's 1 over -1. So it's this point right here. It's 1 over -1. And then what happens is we get to smaller and smaller negative numbers. Well, think about it. If you have -1/2 here, if when r is -1/2, it goes to -2, and it just keeps it's actually going to asymptote, right? We only care about this interval, so it's going to look something like this. It's going to asymptote to -infinity, right? If I kept drawing this all the way down, that would just asymptote. And then what is h of 3? Well, h of 3 is just going to be 1/3. It's going to be a relatively low number. And then what's going to happen as we get closer and closer to 0? Well, if you put a really small positive value here, you get larger and larger numbers, right? So this actually asymptotes to positive infinity. This asymptotes to positive infinity, so it'll look something like this. I always have trouble drawing these hyperbolas. It's going to look something like that. It's going to go to positive infinity. So that goes to positive infinity, and this will, on this side, go to minus infinity. And frankly, just looking at this graph, you see why the graph is not defined at 0. right? From the right-hand side, the limit approaches positive infinity. From the left-hand side, it approaches negative infinity, and 1 over 0 is just undefined. And well, similarly, that's why you couldn't get a derivative there either, because the definition of the derivative means you're taking a limit, and the limit has to be valid from both directions. And as we see, the limit is not valid from both directions here. So what are the maximum and minimum points here? Well, if we look at this value, we might say, oh, is that a minimum point? Well, no, because you have values much lower. Actually, you have values that go to minus infinity in this interval. And then you say, well, is this a maximum point? Well, no, you have values that go to positive infinity in this interval. So it actually turns out that there is no, I guess you could call, this isn't very proper, but to some degree, at 0, you're at both positive and negative infinity, depending on what direction you're coming from. But this really has no maximum or minimum points, because the graph is undefined at 0. And then, if I said, oh, well, what if I get really close to 0, and I call that the maximum point? Then you say, no, but there's a point even closer that has even a higher value, that's even closer to infinity. So there is actually no exact point that is the maximum value. So that's kind of interesting. Anyway, I'm already at 11 minutes, and people have YouTube apparently lets me go well past the limit now, but people have told me that they like the 10-minute nuggets of knowledge. So I will stop now, and I'll continue these problems in a future video. See you soon.